Banch fixed point theorem. State and prove the Banch contraction principle statement. Let XD be a complete metric space and let phi be a contraction mapping on X, then there exists one and only one of small x belongs to capital X such that phi of X equals to X. Proof: let x0 be an element of X defined on a sequence Xn. In X follows x1 equals to phi x0, x2 equals to phi x1, so on. Xn plus 1 equals to phi xn for n equals to 1, 2, 3 and so on. Since phi is a contraction map, there exists a real number alpha belongs to R with 0 is less than equal to alpha is less than 1, such that for all xy belongs to capital X, we have d of phi x phi y equals to alpha d of xy. We shall show that the sequence xn is a Cauchy's sequence for each positive integer, and we have d of xn dxn plus 1 equals to d of phi xn minus 1 phi xn, so equals to alpha d of xn minus 1 xn, which is less than equal to of alpha d of phi xn minus 2 phi xn minus 1, so which is less than equal to alpha square d xn minus 2 xn minus 1, so on, which is less than equal to x raised to n d x0 x1. It follows that if m and n are the positive integers and m is less than n, say then d of xn is less than equal to of d xm plus 1 plus distance of xm plus 1 of xmn plus 2 plus so on plus d of xn minus 1 of xn, which is less than equal to of alpha raised to m d of x0 x1 plus alpha raised to m plus 1 d of x0 x1 plus so on plus alpha raised to n minus 1 d of x0 x1, which is equal to alpha raised to power m into 1 plus alpha square plus so on plus alpha raised to n minus m minus 1 into d in distance of x0 x1, so equals to alpha raised to m into 1 minus alpha raised to n minus m into d of x0 x1 upon 1 upon alpha, because 1 plus alpha square plus so on plus alpha raised to n minus 1 is a GP series where a equals to 1 and the common ratio alpha and the number of the terms n minus m. Therefore s equals to a 1 minus r raised to power n upon 1 minus r equals to 1 into 1 minus r raised to n minus m upon 1 minus alpha, which is less than alpha raised to power m. Distance of x0 x1 upon 1 minus alpha tends to 0 as m tend to infinity. It now follows that sequence xn is a Cauchy's sequence, but x is given to be the complete, therefore there exists a point x small x belongs to capital X such that the limit x n tend to infinity xn equals to x. Further, since a is a contraction map, phi is a continuous, so phi of x equals to phi of limit n tend to infinity xn equals to limit n tend to infinity phi of xn equals to limit n tend to infinity xn plus 1 equals to x. Hence phi of x equals to x, which shows that x is a fixed point of x, capital X. Now we shall prove that x is unique. Let y belongs to capital X, y is not equals to x, and phi of y equals to y. Then distance of xy equals to distance of phi x phi y, which is less than equal to alpha of distance of xy by the definition of the contraction mapping. So distance of xy minus alpha of distance of xy is less than equal to 0, which implies 1 minus alpha into distance of xy is less than 0, as alpha is less than 1 and distance of xy is greater than 0. Therefore we must have distance of xy is 0, which is equals to x, which implies x equals to y.